Today we're going to be learning how to solve a system of equations by substitution. Before we get into that, I want to briefly talk about what this idea of solving has always meant. Solving always means to find the values of the variables that would make a true statement if plugged into the formula. If you look at this first problem, this is clearly something that we have handled before. We get x alone, and as you can see, we add 10 to both sides, we divide both sides by 3, and we get an actual number 4x. If I asked you to solve this particular equation for x, you could get x alone, but you wouldn't get a number value for x because of the presence of a y. As you can see, I can bring the 3y over to the other side, then divide by 5, and the resulting thing is an expression that has a y in it, so I don't get a number value for x. When we solve a system of equations, what we really mean is we'll have two equations to work against each other, and our aim is to find the value of x and y that work in both equations. You can see the list of steps. Isolate either variable. It doesn't matter which equation you focus on. Once you have that value, substitute it into the other equation, solve the resulting equation, and then substitute the value that you find into an earlier equation to find the other variable's value. You can see this problem right here. If I wanted to make life easy for myself, the variable that looks easiest to isolate is the y in the bottom equation. So I'm going to bring the 7x over to the other side by subtracting 7x to both sides. Now this quantity right here is equivalent to y. This equation tells us so. So I'm going to substitute that value in place of the y in the other equation. So I'll rewrite the other equation, 3x minus 5. Instead of writing the y, I'm going to put in its place what y is equivalent to. So the negative 9 minus 7x goes right in place of where there was a y, and then equals negative 31. So this is the top equation, but where there used to be a y, I've now substituted the value that y was equivalent to. Do you see that the equation we have only has x's in it now? That should be the case. I'm going to distribute the negative 5 through, so plus 45 plus 35x equals negative 31. I'm going to add the two x terms that are on the same side of the equation. You can just add them directly whenever they're already on the same side of the equation. Now I'm going to get the 45 over to the other side. 38x equals, and then I have here a negative 76. And now I'm going to divide by 38 on both sides. And even though it looks kind of scary, your calculator will quickly confirm for you that x equals negative 2. We now know the value of x. To find the value of y, we're going to have to resubstitute our value of x into an earlier equation. Doesn't matter which equation you use, but it's usually easiest to substitute it in the equation that has the y already isolated. So negative 9 minus 7 times the value we found x to be, negative 9 plus 14, and you can see that's going to give us 5 for our answer. So y equals 5. Just like we frequently list x and y values as ordered pairs, you'll often find the answers written in the same manner. So they'll write them as an ordered pair. They'll put the x coordinate first and the y coordinate second. And we'll talk more on a later date about what it is we've just found graphically But for now, it's just an algebraic solution that gives us the value of x and y that would make a true statement in each of the two equations. Here's a second system for you to try. At this stage, I suggest you pause the video and try this problem on your own right after you write this problem down. Now that you've tried this one on your own, let's go through the solution so you can check and see if you've understood. In this case, it looks like the variable easiest to isolate would be the x in the top equation. Pretty much any time there's a 1 or a -1 for a coefficient of a variable, that's the easiest variable to isolate. So I'm going to isolate the x in the top equation, and the way I'm going to do that is by bringing the y term over to the other side. So it'll equal 33 minus 4y, because the way we get the 4y over is actually by subtracting. Now we're going to substitute that in the second equation. So since the second equation starts out with a 6x, I'm not going to write the x part. I'm going to put in place of the x what I know x is equivalent to. So the quantity that I have right up above. Minus 10y equals -40. So as you can see, we have an equation now with only one type of variable, and we're going to solve for y. 6 times 33 would give us 198 minus, and then the 6 times the -4y would be -24y minus 10y equals -40. Let's go ahead and combine our two x terms. 198 minus 34y equals -40. Now let's go ahead and subtract 198 from both sides. And we end up with -34y is equal to, and that's going to be -238. Let me see if I've got that right. Now I'm going to divide by a -34 on both sides. And again, the numbers look a little scary, but your calculator will quickly tell you that y ends up equaling, and that's a positive, because it's negative over negative, 7. So y is 7, and we can use that information to help us find x. X is equal to 33 minus 4y, according to this equation that we started with. And let's go ahead and put in our 7. So x is equal to 33 take away 28. And it looks to me like x has come out to the value of 5. So if we were to write our answers as an ordered pair, we could write it as 5, 7. You could also just box up your two values and report your answer like that for now. Here are 4 problems that I want you to try for tonight. Please show all of your work, because if you have trouble, I want to be able to look and see where you're getting stuck. Do them for homework and bring your work and your answers to class. For your convenience, I have also put this in a Microsoft Word document, and I will upload that as well in case you don't want to sit there looking at the screen to write down all 4 examples. Have a good night.